चले अच्छा so what we did was कि higher potential gains electrons, right, and lower potential loses electrons. ठीक है, that is something that we did basically. ठीक है, we did electrode potentials and I told you that if something likes to, अगर उसका भी थोड़ा सा brief overview दे दे कि I told you that if some substance wants to lose electrons, a lot of electrons would accumulate on the electrode and it's going to have a very low potential. Okay, that's what we did. So lower potential means that it likes to lose electrons. Vice versa, if something likes to gain electrons, like Cl2 over here wants to gain electrons. So if Cl2 really wants to gain electrons, the metallic electrode over here will be electron deficient. Because सारे electrons जो है वो Cl2 gain कर लेगा. It's going to gain all the electrons and it will become positively charged, right? So higher means that it wants to gain electrons. Lower means it wants to lose electrons. Now, so that's the basic idea. High E naught gains electrons, lower E naught loses electrons. And I told you that it's a relative comparison. Okay, so if someone is higher, the other one is lower, the higher one will gain electrons. We did electrochemical cells. We learned how to draw them. This was one example that we did. Okay, by using electrode potentials, you can predict what is the reaction that's going to happen. So for example, if I put these two electrodes together, iodine electrode next to potassium. So I told you that the higher one gains electrons, right? So this thing 0.54 over here will gain electrons. And the lower one likes to lose electrons. So potassium is the one that's going to lose electrons. So it's going to go in the backward direction. On their own, they're in equilibrium. Okay, if they're completely isolated, they're in equilibrium. But when you keep two electrodes together, then one of them gains and the other one loses. They are no longer in equilibrium. Or वो आपने decide करना है who's going to gain, who's going to lose, right? And you can come up with the equation that the iodine one gains electrons, so write it in the forward direction. The potassium one loses electrons, so write it in the backward direction. And make the electrons gain and lost equal, and add the two reactions up, and you'll get the overall reaction. And you can measure the E naught cell. The E naught cell is the potential difference that will decide how fast the reaction is going to happen. Yeah, agar E naught cell that's very large, then the reaction will happen very, very quickly. Okay. If the E naught cell is very small, if the potential difference between the two electrodes is not that much, then the electrons would flow very slowly, and it's going to be a slow reaction. So this is a summary of all that we did. Okay, so all you have to do, higher gains, lower loses. But in the previous class, I told you that the question is not going to be this simple. That iodine is not, like over here, iodine had a single electrode. Potassium ions, they had a single electrode. Sometimes what will happen is, most of the times what will happen is that if I want to predict copper's reaction with FeCl3, so I wrote down steps, like how would you predict the reaction? Because now there are multiple possibilities. The reason there are multiple possibilities is that copper has many electrodes. Copper could turn into copper 2 plus. Copper is in equilibrium with copper 2 plus. Copper can also turn into copper plus 1. So copper has multiple options. It could do both things, right? So now you've got multiple electrodes to choose from. It's not just going to be two electrodes. It's going to be multiple electrodes. Okay? Fe3 plus similarly. Fe3 plus could gain 3 electrons to form Fe. Fe3 plus could also gain 1 electron to form Fe2 plus. So again, there are multiple possibilities. Cl minus 1, there's only one possibility. So I told you that what you do is you identify the reactants that you have. So you've got 3 reactants. You've got copper, you've got Fe3 plus, you've got Cl minus 1, right? You've got 3 reactants. And out of those 3 reactants, what you're going to do is you're going to write down all possible electrodes, because you don't know what's going to happen. You don't know what's going to happen to Fe3 plus. So you write all electrodes that involve Fe3 plus, whether they're gaining electrons or losing electrons, just write all of them. Same is the case with copper. You're going to write all electrodes that involve copper. And then once you have all the options, you don't have to write all these equations. You can just mark them on the data sheet. The table would be given to you. All you have to do is you have to figure out of all of them who has the highest E naught, because that's the one that is most likely to gain electrons. And who has the lowest E naught, because that's the one that's most likely to lose electrons out of all of them. But whatever you choose, it must be one of your reactants. It has to be either copper or Fe3 plus or Cl minus 1, not something else, because these are your 3 reactants. तो जब मैंने select किया था ना कि high E naught gains electrons, so what I did was I figured out that the highest E naught was 1.36. That was Cl2 gaining 2 electrons to form Cl minus 1. But जब मैंने ऊपर देखा ना, I found out I didn't have Cl2. I had Cl minus 1. I did not have Cl2. ठीक है, so based on my highest E naught gains electrons, it would have been Cl2, but I can't use that equation because I don't have Cl2 in my reactants. So I cut that out. I removed that. Then I searched for the next highest E naught, and I figured out that the next highest E naught is 0.77. That's Fe3 plus gaining 1 electron to form Fe2 plus. That's higher than all the other ones. Then I figured out, do I have Fe3 plus in my reactor? Then I figured out I do have Fe3 plus, right? So that's why I chose this equation. This is the highest one. Or for lowest, lowest I'm going to choose who loses electrons, right? Lowest came out to be, it wasn't this one, it was minus 0.04. So lowest one loses electrons, but it's Fe that's losing electrons. And I figured out that I don't have Fe in my reactant, so I can't use this equation. So I searched for the other lowest equation, which came out to be 0.34. And in that case, copper was the one that was losing electrons. So I figured out that I do have copper in my reactant. So this equation is fine. So करना मैंने वही है, I have to figure out highest E naught gains electrons, lowest E naught loses electrons, but it must be one of my reactants that's losing or gaining electrons, not someone else. Okay, so once I figured out lowest and highest, I just wrote down the overall equation, and I got the two equations together. Okay, copper losing electrons, Fe3 plus gaining electrons, and I came up with the overall reaction that's going to happen. Okay, and the E naught cell was the potential difference between the highest and the lowest. So ठीक है, ये सारा clear है पिछला वाला, ये पिछला मैंने एक summary दी है. Is this clear, Shan? Omar? I mean, we'll do more examples now. ठीक है. So we'll just do more examples of this, similar questions. So let's try, but remember the steps. Do you remember the steps? I said now, just to make things quicker, I'll just do all the working on the data booklet. I mean, it's a waste of time to copy all the equations. So I'll just do all the working on the, identify the reactants. That's the first step. And treat them as ions. Like FeCl3, there's no such thing as FeCl3. It's got two things. It's got Fe3 plus and it's got Cl minus 1. You see that NaCl is not one thing. It's Na plus 1 and Cl minus 1. So treat them as ions. Identify all the electrode reactions that involve this. Something would happen to them. Whether they lose or gain electrons, we don't know. Figure out who is the highest one and who's the lowest one. But it must be your reactant. It must be one of these three. कोई चौथी चीज नहीं होनी चाहिए, ठीक है? Anyways, let's start with another question. So I've got a reaction and I want to figure out what's going to happen over here. I've got Cl2 reacting with KBr, right? And Cl2 is, forget what the state is. So Cl2 reacting with KBr. So step number 1. Now, I already know from O levels, I know what's going to happen. Cl2 is more reactive, so it will displace Br, or it will oxidize Br minus 1, right? And so step 1 is identify the reactants. So let's do that. The reactants are, I mean, one of them is Cl2, obviously. KBr is made up of two things. It's K plus 1 and it's Br. And it's Br minus 1, right? So that's step number 1. Then step number 2 is I'm going to identify all reactions. So identify all electrodes. That involves these three. So we're going to open the data booklet for this kind. Just a second. So the data booklet, remember I've got Cl2, I've got K plus 1 and I've got Br minus 1. Achha, so these three, Cl2, K plus 1, Br minus 1. Here is my all my electrode equation. So I'm going to do all the working over here. So here I have Cl2. So that's Cl2. So I'm going to select this equation, Cl2. Then I've got K plus 1. That's K was over here. And remember, I had K plus 1. So K plus 1 could gain 1 electron, right? And I've got Br minus 1. B must be at the top. I had Br minus 1. So I've got three potentials, 1.07, and there's 1.36, and there's one for K as well, which is right at the bottom. That's minus 2.92, right? Starting with the first one, who gains electrons, right? Who gains electrons? The one that has the highest potential gains electrons. So minus 2.92, 1.36, and 1.07. So who is the highest in Sarome? That's 1.36, right? So that means that is the one that's going to gain electrons, right? And TK, that's fine because I do have Cl2. I've got Cl2. So Cl2 is the one that's going to gain electrons. So it is one of my reactants. So that's fine. I've figured out who gains electrons. Now I have to, Yada clear? Shian, Risha, Asim, Uzair, clear? So then I have to figure out who's going to lose electrons, the one that is the lowest. So 1.07, 1.36, which one is the lowest? The lowest is minus 2.92. So although this is the lowest, right? So this is supposed to lose electrons. But I can't use this equation. I can't use this equation because I don't have potassium with me. Okay, if I choose this as the lowest, then potassium is the one that's going to lose electrons. But remember, in my reactants, I have potassium ions. I don't have potassium. Okay, so there is no potassium. So which is why I'm going to completely reject this equation. You be clear? So I'm just rejecting this as the lowest. It's not going to work. So coming back to this, now out of these two, which one is the lowest? The lowest is this one, right? This one is the lowest. And Br minus 1 is going to lose electrons, right? So that makes perfect sense. I do have Br minus 1, right? So from this, I figured out who gains electrons, who loses electrons. ठीक है? ये clear है? और वो ये clear है कि मैंने potassium को क्यों reject किया? ठीक है? Is this clear? Yes or no? Clear है? So I'm just going to just from the data booklet, I figured this out, and you look for the electrode value does not change. Remember, the electrode is for the equilibrium. Whether it's forward or backward, the electrode value is the same. It doesn't matter. Okay. It will not change. But you look at the reactants, like what I mean, if it's the lowest, I mean the products can be anything. It can be anything. Reactants वो होने चाहिए जो आपके पास है. Like if I select Br minus 1 losing electrons, I do have Br minus 1, right? If I select highest, this one, Cl2 gaining electrons, I do have Cl2 over here. So it makes sense. The reason I did not select potassium as the lowest one was that if I had selected this as the lowest, then potassium would have been the one that would have been losing electrons. I don't have potassium. Okay, so you're going to look for the reactants. The products could be anything. Oh, Br2 burner, I don't care. I don't care what's happening to it. As long as I do have Br minus 1. Okay, that's my reactant. Okay, the product could be anything. It could turn into anything. So you've got these two reactions, and I'm going to write them the other way around now. Okay, what I'm going to do is this one, Br minus one, losing electrons. So Br minus one, two of them.
Excuse me, sir.
Haji.
This is the equation saying that the potassium ion gains electron and the value is minus 2.92. But we reverse the reaction, so won't it be plus 2.92?
एक second. See, this was the lowest out of all the three. This was the lowest, right?
But sir, it is for potassium ion converting into potassium metal. But if we taking it as potassium,
there's a reversible sign. This is for both backward and forward. When you have an isolated electrode, the reaction is going in both directions. Okay? It's only when you connect it with some other electrode. ठीक है वरना isolated ये था ना कि an isolated electrode would have an equilibrium. It's only when you connect it with some other electrode do the electrons start flowing from the lower potential to the higher potential, and the equilibrium is disturbed. The lower hoga na, that would start losing electrons, the higher one would start gaining electrons. Okay? That's the only point when the equilibrium is no longer there. Ab aapka question jo na, that is that this minus 2.92 is both for the forward and the backward. Is that clear? It's for the reversible reaction. You clear?
a bit, it's still a confusion because if we talk about equilibrium in a reversible reaction, delta H value is minus for the forward in case. For the backward reaction, it becomes positive.
This is potential. Potential will not change. I mean, this is sodium electrode. If you look at the sodium electrode, right? In an isolated system, sodium would always like to lose electrons. So the electrode would always have a lot of electrons on it, and it will always have a negative potential, right? Is that clear? Okay, but at some point it will be in equilibrium with its ions, right? So it will always have a negative potential. It's only when you connect it with some other electrode तब होगा कि क्या इधर से इलेक्ट्रॉन उधर जाएंगे या उधर से इलेक्ट्रॉन इधर जाएंगे ठीक है then it will start gaining or losing electrons depending on this other electrode ठीक है once it's forming an electrochemical cell मतलब ये वाला काम होगा ना अच्छा अभी in what direction are the electrons flowing बल्कि इसको छोड़ो if you look at this one you've got a sodium electrode right minus 2.71 volts right. What if I had a potassium electrode over here? That was minus 2.92 volts. So electrons की direction क्या होती है? वो इधर होती है ना इस direction में. Is that clear? So whether it's going to go in the forward or whether it's going to go in the backward, that depends on this other electrode. What does it want to do? कि उसका potential lower है या higher है? अगर यहाँ पे potassium electrode होता, this would have been minus 2.92 volts, right? It would have been even more negative. So electrons always flow towards the electrons would start flowing in the other direction. Okay? So remember this, okay, the electrode potential is for the electrode. Whether it's gaining electrons or whether it's losing electrons, it depends on this other electrode. ये बात समझ आइए?
Yes, sir.
Okay? So remember this value does not change. Achha, but some books and some places you will see that they will say that the value changes. Okay? So it's not the value that is changing. Okay? The value remains the same. When you calculate the E0 cell, right? What do? It's higher potential minus lower potential. You take the potential difference, right? It's reduction potential minus oxidation potential. Remember, the value is not changing. Like in the potential difference, like in physics, how do you calculate potential difference? Higher potential minus lower potential. So when you take a minus sign over here, what happens to the sign of this other potential? वो क्या हो जाता है? Change हो जाता है ना? Because you're taking a difference, right? So Abhi, do you get the point? It's not the value that is changing, although the sign is changing, right? When you take the E0 cell, it's higher potential minus lower potential. When you take the difference, तो ये इस वाले का ना sign change हो जाता है. So just remember that that does not mean that the potential itself is changing. It's just that you're calculating the difference between the two. ठीक है, Abhi, is this clear? So coming back to this. So just remember this. that potassium, whether this reaction goes backward or whether it goes forward, the potential is still the same. वो जब difference निकालोगे ना, potential difference, that's when you take the difference, when you take the minus sign, that's why the sign changes. But तो इसलिए वो if in a lot of books, even some teachers, they tell you that उसको reverse करोगे ना, the potential changes. It's not changing actually, it's the same, it's exactly the same. ठीक है, you're just calculating a difference, that's it. अच्छा, coming back to this, ये वाला कर लें कि so I'm just going to complete this reaction that but is this 100% clear that why did I reject potassium? वो clear है ना, potassium, why was it rejected? So I've got anyway, so I've got so I've written the Br minus 1 equation in the backward direction, and the Cl2 equation will be written in the forward direction. So that would be Cl2 plus 2 electrons, and you can construct the overall equation. The electrons are equal, gained and lost. So it's going to be 2Br minus 1 plus Cl2 plus and the product is going to be Br2 plus 2Cl minus 1. That's your reaction. And the E0 cell will be higher potential minus lower potential. So it's going to be 1.36 minus 1.07. So I'm just going to repeat it. It's not actually minus 1.707. It's you're just calculating the difference between the two. ठीक है, वो ये नहीं है कि वो backward जा रहा है तो it's minus 1.07. You're just calculating a difference, and the difference comes out to be 0.29 volts. I guess you check कर लेना. So you're getting 0.29 volts for this. So that's it. That's how you've been able to predict the reaction. So I'm going to do another easy one. Okay, let's try. So your final end reaction. Okay. So let's try another easy one. Okay, let's say I've got a displacement reaction. I've got Na reacting with AlCl3. Now I'm pretty sure that Na is going to displace Al. N is more reactive. O levels, okay? N is more reactive. As the first thing, identify your reactants. You've got Na, okay, that's your reactant. You've got Al, that's 3 plus, and you've got Cl minus 1. So जो भी होगा इन तीन के साथ होगा. These are your three candidates. Someone out of these three is going to lose or gain electrons. So starting with Na, I'm going to mark equations for Na. एक ही होगी. There's probably just one. So, where's Na? I'm going to use a different. Blue में होगा. Na is over here. So there's Na minus 2.0 minus 2.71 volts, and I've got aluminium, which is 3 plus. Remember, I had 3 plus, so that's Al3 plus minus 1.66. Up is Cl bhi tha, Cl minus 1. So let me get rid of this. So I'm going to mark an equation for Cl minus 1 as well, which is this one, 1.36. I'm not going to use this equation because there's another equation for Cl minus 1, but in that case, Cl minus 1 reacts with 2 OH minus 1. ये दोनों इकट्ठे होने चाहिए. Cl minus 1 is reacting with 2 OH minus 1. The reason I'm going to reject that is I don't have that OH minus 1, but there is no OH minus 1 here. ठीक है, जबकि वो equation में he was asking, I mean, there was Cl minus 1 next to OH minus 1. ठीक है, so So I'm going to reject that particular equation. So this one is rejected. And there's probably no other Cl minus 1 equation. So anyways, we're dealing with 3 equations. So highest potential gains electrons. So highest at the moment is 1.36. You get one of them is minus 1.66, then you have 1.36, and then there is Na right at the bottom, which is minus 2.71. So highest तो वही बन रहा है, that's 1.36, right? So highest gains electrons, which means this reaction will move in the forward direction. It's going to gain electrons. So I'm not going to use this reaction. Why? Because I don't have Cl2. There is no Cl2 in my reactants. But if there is no Cl2, how would it gain electrons? That's not possible. So there is no Cl2. Okay? So it's clear that this stands rejected. Okay, is this clear? Disha clear है? Shan, see. ये reject हो गया, and Abi, is this clear? आवाज आ रही है? अच्छा, तो उसको अब छोड़ दो, वो highest मतलब नहीं हुआ. That's not the high. I mean, it is the highest, but I don't have Cl2, so how can it gain electrons? So who's the highest now? I've got minus 1.66. अच्छा, now I've got minus 1.66 और वो दूसरा minus 2.71 है, ठीक है? So अब इन दोनों के बीच में competition है, तो highest तो वही है, that's minus 1.66. And that's the one that's going to gain electrons, and that's fine. I've got Al3 plus, it can gain electrons, so that's fine. So there's nothing wrong with that. And the lowest is minus 2.71, so that is the sodium one, right, over here. And I do have sodium. Sodium would lose electrons, so that's fine. There's nothing wrong with it. Okay. But jo bhi choose karo na, you should have it. It should be your reactant that is gaining or losing electrons. So I can make the overall equation now. I've got so basically in तीनों के बीच में था, you got Na plus 1. Just let me write that quickly. Na plus 1 plus 1 electron, and it was in equilibrium with Na, and that was minus 2.71 volts. And then I had Al 3 plus 3 electrons, and that was in equilibrium with Al, and that was minus 1.66 volts. And then the reject we that was Cl2 plus 2 electrons. And that was 1.36 volts. So you had these 3 reactions. This one was rejected, okay, because you didn't have Cl2. It was the highest, but since you didn't have Cl2, how can it gain electrons? Okay, that was rejected. It was this was the highest, and this was the lowest, and you had both things. Okay. Remember, product में जो मर्जी बने, we don't care about the product as long as we have the reactants. So this was the lowest, and this was the highest, and you can come up with an equation for that. The equation will be Na को सीधा करके लिखो, it's going to be Na, and that's turning to Na plus 1 and losing 1 electron, and Al3 plus, that's gaining 3 electrons, and that's so you can make the equation. That's what is the equation? You have to balance the number of electrons gain and loss. So this will be multiplied by 3. ताकि वो electrons. So it's 3 Na plus Al3 plus And the product is going to be 3Na plus 1 and plus Al. So you saw it. Alicia, the reason we didn't use Cl minus 1 was that it was the highest out of all of them, right? So agar highest select karna tha, this was the highest, right? So I should have used this one. Highest kya karta hai? It's going to gain electrons, right? It's going to gain electrons, and so who's going to gain electrons? It's going to be Cl2 that gains electrons, right? I don't have Cl2 in my reactants. But मेरे पास Cl2 है ही नहीं. I've got Na, I've got Al3 plus, I've got Cl minus. So I don't have Cl2. So I can't use this equation because, is that clear? So बस जो भी है ना, जब आप equation select करोगे ना, you should have that. I mean, it should be one of these three things. In तीनों में से someone is going to gain electrons and someone is going to lose electrons. ठीक है? Nothing out of these three that is not present in these three. It should be your reactants that should be gaining or losing electrons. So you found out the overall equation, and you can figure out the E0 cell, which is up at the bottom. Repeat karo. The sign is not changing. You're just calculating a potential difference. Higher potential minus lower potential. So it's minus 1.66 volts minus the other one, which is minus 2.71. So jo bhi aayega, you're going to get what? 1.05? I'm assuming it's 1.05 volts. You're going to get a positive potential. So अब 5. It should be 5. Achha, now let's move to a slightly, but the same thing, but slightly more difficult question. This was easy, right? So let's try and do a reaction and try and figure out the reaction. Okay, now this is exactly the same, but it's going to have a lot more things. Okay, it's FeSO4 aqueous reacting with K2Cr2O7 acidified. I mean, you must have seen this equation many times, right? It's potassium dichromate 6 with FeSO4. So now it's the same thing, same question, except with a lot more things. So who are your ions in this case? You've got Fe2 plus. You've got SO4, which is 2 minus. You've got K plus 1. So you've got Cr2O7 2 minus. And you got acidified, which is H plus 1, right? So now you've got a lot of things. Fe2 plus. Fe2 plus. So I'm going to open the data booklet, figure out what happens to Fe2 plus. Now many things can happen to Fe2 plus. So let's try and figure out and do all the working here. Okay, so let's go with Fe2 plus. So I've got Fe2 plus over here. That's 1. And then I've got Fe2 plus over here as well in this other electrode. So I figured out 2 reactions that Fe2 plus can undergo. It can either gain 2 electrons, or Fe2 plus in the reverse direction can lose electrons to form Fe3 plus. So you got 2 possibilities for Fe2 plus. Achha, agle pe aa jao. Okay, just FeSO4, right? SO4 minus 2. Look for SO4. Where is? Let me rub this off. So now SO4 minus 2. What can happen to SO4 minus 2? This thing can happen. So remember, the solution is acidified, so it's fine. SO4 minus 2 with acid H plus 1. We do have acid in the solution, so ye ho gaya. Achha, there's another one. So SO4 minus 2 can gain electrons. It can also. So there's 2 reactions. One in which it's gaining electrons to form SO2. The other one where it's losing electrons to form S2O8. Achha, potassium dichromate 6, potassium K plus 1, right? Achha, where's K plus 1? Only one reaction. So only one possibility for K plus 1. Achha, then you have Cr2O7 2 minus, right? So where's that? Just one reaction, Cr2O7 2 minus, right? And you had H plus 1 as well, right? So let's write an equation for H plus 1 as well. That's H plus 1 can change into H2 as well, right? So I've got all these possible reactions. And there are lots of them. And we're going to do the same thing. Do either. So remember, higher potential gains electrons, right? So 2.01, 0.17, higher potential gains electrons. Who's the highest? Highest is 1 point. Out of all my potentials, this is the highest. So this is the one that's going to gain electrons, right? Do I have Cr2O7? I do have Cr2O7. Do I have 14H? I have H plus 1 as well, right? Ye tha na. I had Cr2O7, I've got H plus 1 as well. So that's fine. That was easy. I figured out who gains electrons. You clear? ये पहला part clear है कि who gains electrons. ठीक है, 1.33, that's fine. Shia, Naseeb, Alicia, is this clear? Zaid. Achha, so now who loses electrons? The lowest potential, right? So पहले तो ये minus 2.92 lowest, right? Loses electrons. But I can't use that. I don't have potassium. I had potassium plus 1. I didn't have potassium. Potassium losing electrons does not apply. Okay, इसको निकाल दो. So which one is the lowest now? Minus 0.44 loses electrons, right? But I don't have iron. I have Fe2 plus. I don't have Fe. So I'm going to reject that as well. अच्छा, who's the lowest now? वो भी था एक मेरे ख्याल से अगले पेज पे. That's अच्छा, the lowest is 0. That's hydrogen. This is the lowest, right? It's going to lose electrons. But again, I don't have hydrogen over here. I don't have hydrogen. I have H plus 1, but I don't have hydrogen. So hydrogen cannot lose electrons because I don't have it. उसको भी reject कर लो. अच्छा, who's the lowest now? Equal space पे you got 0.17, right? अच्छा, so 0.17 is the lowest. So 0.17 is going to lose electrons. It won't because I don't have SO2. ठीक है, SO2 cannot lose electrons. Achha, who am I left with? I'm left with 2.01. I'm left with 0.77 over here. Then Sarome, the remaining one's 0.77. That is the lowest, right? And can it lose electrons? Yes, it can. Because I have Fe2 plus. And it can lose electrons. Baki sare reject isliye hue hain. The reason they got rejected is that I didn't have them. Potassium was the lowest. I didn't have potassium. H2 was the one that was the lowest. It can lose electrons, but I didn't have H2. Fe was the lowest, minus 0.44, but it can lose electrons, but I didn't have Fe. So all the others got rejected, and the lowest out of the remaining was this one. So the final end result is it's Cr2O7. That's one. So बस इसको खत्म करते हैं. अच्छा, so out of all of them, ये मेरा end result है. बाकी काम खुद ही कर अगली बार कर लेते हैं, ठीक है? Okay, I've finally managed to select which one is the highest, which one is the lowest. All I have to do is I just have to single out these equations. One of them reaction is this one, the reduction reaction, and this is my oxidation reaction, and I'm going to add up both reactions. Okay, that's it. So ये clear है? ये question clear है? Is this clear? कुछ समझ आया था? उमर, शान, उज़ैर, आबिया? अच्छा, किया हमने वही है, ठीक है? Just make sure you remember all the steps, ठीक है? And ठीक है, and if you do the working on the data booklet, it would be, things will be quicker. we'll practice more questions. There'll actually be more difficult. There's another version of questions which is even more difficult. So I mean, there would be how am I करता हूँ, ठीक है? So there's going to be a version of questions which is going to be even more difficult than this, ठीक है? So एक step और भी है थोड़ा difficulty level का, so we'll do that in the next class. चलो worksheet भी मैं शेयर करता हूँ. चलो okay everyone.